Hello everyone, welcome you again to today's class and today's topic again in continuation with applications of integral calculus and the special emphasis is on finding area of the region bounded by two curves. Okay, so in today's class we will discuss areas of the region bounded by two parabolas, parabola and line and parabola and circle. Right? So let's begin the class. Sir, first question is, yeah. So since already we had started the basics of the topic and we already have finished two lectures on this class. So no need to repeat the steps of the solution and also the basics again and again. So I'm sure you already have done the basics of the topic. So let's start the question in a, in direct manner. First question is, so I have considered first two questions in fact the area of the region bounded by parabola and line. Okay, the first question is find area of the region bounded by the curve x square equal to 4y, which is the parabola, and the line x equal to 4y minus 2. Okay, and going to the steps of solution. Step 1 is finding, drawing the rough sketch. So to draw the rough sketch, so we need the basics like analyzing the curve also. So here you see, as I said, x square equal to 4y. So that is basically, so this is a parabola. Okay, this is a parabola which opens towards, towards upward direction. Okay, so this is the curve we have x square equal to 4y, right? And the line x equal to 4y minus 2. So to draw the line, what you can do, you can take xy the way you draw. You take 2 points and join them to, draw the line. You can do like this. So when y equal to 0, x equal to minus 2. Similarly, when x equal to 0, if x 0, y will be what? X 0, so 4y equal to 2, y equal to 1 by 2. Okay, so this is the way we have drawn the graph. I have used the GeoGebra software so that drawing the GeoGebra and using snipping tool, I have, uh, uh, taken the rough sketch here. Okay, otherwise we will do that in the exam. We will be doing it manually. So anyway, this is the parabola x square equal to 4y, and this is the line which is represented by what? X equal to 4y minus 2. Okay, drawing the rough sketch is over. Next, shading the region, and you can clearly see the region bounded by the curve and the parabola and the line. Okay, are you able to see it? Okay, so now let me just take, drawing the rough sketch. I will take some good color. Yes. Okay, so here you see, this is the color. I am just taking yellow color. This is the region we need. Okay, so this is the region we want to find out area. Okay, now just see, third step is finding limit. So finding limit, you can see where the line and the parabola intersects. Just mark the boundary like this. Okay, so here you can see, to start the question like this, given curves are, given curves are, first one we are writing x square equal to 4y, okay, or you can write here y equal to x square by 4. Okay, this is your first equation. Second equation is the line is x equal to 4y minus 2, or you can say y equal to x plus 2 by 4. Right? These are the two curves given to us. Okay, we have drawn the rough sketch, shaded the required region, the area, we want to calculate. And third step is finding limits of integration. So it means to get limits of integration, we have to solve the two equations of the curve. Okay, now equating equation 1 and 2. Equating equations 1 and 2. So here y equal to x square by 4, here y equal to x plus 2 by 4. So it means we can say, equating two equations, x square by 4 equals to x plus 2 divided by 4. So this implies your x square equal to x plus 2, or you can say x square minus x minus 2 equal to 0. So this implies x square minus 2x plus x minus 2 equal to 0. Okay, so this step, so next step is, here you can say x minus 2 into x plus 1 equal to 0. It means we are getting x equal to 2, x equal to minus 1. So here you can clearly see in the figure also. So one point is here x equal to minus 1. Here you have x equal to 2. So while getting area of the region, this yellow shaded portion, so this area we need. So it means we can take area bounded by the line, okay, minus area bounded by parabola, right? So it means required area, so I'm writing it here, area of the required area equal to, it is integral of, we can write directly here, you see, minus 1 to 2 y of line. Y of line means what? That is 1 by 4 of x plus 2 dx, right? Y of line minus, again it is minus 1 to 2 y of parabola. So y of parabola is what? 1 by 4 of x square dx, right? So this is very, very simple integral in fact. So 1 by 4 you can take from the whole thing. Okay, now you see this is your x square by 2 plus 2x, limit from minus 1 to 2. Okay, now here it is minus, it is x cube by 3. Okay, limit from minus 1 to 2. In fact, since because you have the same limit, you can do it directly also. It's not a problem. So 1 by 4 of, so let us take now upper limit minus lower limit. Just let me move this second question a bit. Just give me one moment. Yes. So let's, coming back. Okay, so here you see x square by 2. I am just splitting the terms like this. 1 by 2 of, I am taking x square, upper limit 2. That means 4 minus, at lower limit it's minus 1. Okay, plus 2 into value at upper limit 2 minus value at upper limit minus 1, lower limit minus 1, it will be minus of minus 1 plus 1. Okay. Now minus 1 by 3 of value at upper limit x cube at 2, that is 8, minus value at lower limit minus of minus 1. You are getting here plus 1, right? Okay, so this is equal to what? 1 by 4 of, you are writing here 3 by 2, right? 3 by 2 plus 3 into 2, 6. Now here it is minus 9 by 3, that is 3. Okay. Yes. So you are getting this. So should I just check it again? Yeah, whenever you are taking here 1 by 2, right? So 1 by 2, it is 4 minus 1. Done? Okay. Then plus 2 into, this is 2 plus 1, right? Now minus of, it is 3, 1 by 3 of 8 plus 1. So you are getting here what? So 6 minus 3, 3. So 1 by 4 of 3 by 2 plus 3. That means you are getting what? It is 9 by 8. 9 by 8 square units. Is it clear? Yes. So shall we move to the next question? Yeah, next question is, next question I have taken the similar one so that in one type of question you can be confident of. Yeah, find area enclosed by the parabola 4y equal to 3x square and the line 2y equal to 3x plus 12. Okay, so exactly similar questions. So we can write here given curves are first one is 4y equal to 3x square, or you can say it is your x square equal to 4y by 3, which is a parabola opening in upward direction, right? So this implies what? Y equal to 3 by 4 of x square. This is your first equation. Okay, so this curve, this parabola, it is your 4y equal to 3x square, or you can say y equal to 3 by 4 of x square. Okay, representing the parabola. Second one is, you have 2y equal to 3x plus 12. It means y equal to 3 by 2x plus 6. Okay, so this line, so it is basically 2y equal to 3x plus 12. Okay, so you can clearly see the way to draw the line, right? Here I have used the GeoGebra software, otherwise you can do the freehand graph. We really have to draw the rough sketch in the exam. So okay, anyway, so just you see the line, you can take 2 points and join, you know how to draw the line. Okay, after drawing the rough sketch, shading portion, so area enclosed by the parabola and the line. So area enclosed by parabola and line, that is basically which portion you need to take? Yeah, so this portion is C. This is basically area enclosed by the line and parabola, right? We can shade it. Yes. So drawing the rough sketch and shading this. Okay. So in fact, drawing the rough sketch, whenever you are getting any parabola, so most of the cases, 99% of the cases, you will be getting the standard equations, right? So while getting the standard equations, you should have the idea. Like for example, whenever we say x square equal to 4y form, so x square equal to 4y form, that is basically a parabola whose axis is symmetric about, whose axis, the parabola symmetric about y axis. Okay, quadratic in x, so axis along y axis. Similarly, whenever you get y square equal to 4ax form, so again in that case parabola is opening towards, I mean axis is along x axis, right? And also whenever you say in y square equal to 4ax, if a positive, so parabola opening towards positive direction of that axis. Similarly, yes. So now this is our shading is ready here. Yes, we need this portion. Second step is done, right? So working rule, first step is drawing the rough sketch. Second rule is shading the region whose area to be calculated. We have done it. Third one is finding limits of integration. So unless we have a limits of integration, then how can we, I mean draw, how can we integrate it? Okay, so this is, you see the, I mean intersection point. Okay, this is one, and also this one is another point of intersection. Okay, so you can draw vertical lines just to, yeah, mark the area. Okay, so here I may have, yeah, the line should be like that. So you can draw this in further. Let me make a straight line. Yeah, so basically what I mean to tell you, yeah, drawing the vertical line from here. Okay, so let's find out the point of intersection. So we have two curves. Now, like previous question, yeah, to get limits of integration, we have to find points of intersection of two curves. Okay, what is their common point? So for that reason, we have to equate the given curves. Equations of the curves we have to equate. Okay, so equating equations 1 and 2. So here you have 3 by 4x square y equal to this. In second equation you have 3 by 2x plus 6. Okay, so this makes us, I mean this will make our work simplified. So 3 by 4x square equal to 3x plus 12 divided by 2. So see, solution part, calculation part, that is that you can do as per your convenience. Okay, the way you feel comfortable. So 3x square equal to 6x plus 24. Okay, so we can make it a bit smaller also. So this implies what? Your x square equal to 2x plus 8, or you can say x square minus 2x minus 8 equal to 0. Okay, yes, so here you can write here, see, you can factorize this, right? So it may be, you can write here x square minus 4x plus 2x minus 8 equal to 0. It means x minus 4 into x plus 2. This is equal to 0. So it means the points of intersection you are getting here, x equal to 4, x equal to minus 2, which you can clearly see from the rough sketch. Okay, so this is basically you have to get like this. Okay, this is one point. Yeah, so it is a bit challenging to draw the line correctly, basically, if you are not very artistic or very, yeah. So okay, so this is one point we are getting. So x equal to 4 here, x equal to minus 2. Okay, so once you draw the rough sketch, so again I what I was sharing you the with, I mean the other day. So like here basically even rough sketch you are drawing, no, that should be backed by common sense, right? So it means here when we are drawing x equal to minus 2, x equal to 4, we are getting it, but that should be approximately matched with our rough sketch. Okay, now next, the last part of the solution is what? Getting the area. So here you see, just look at the rough sketch once again. So while getting the area, see, you may take minus 2 to 0, bounded by what? Bounded by, so this is your y-axis, right? X equal to 0. So minus 2 to 0, this line minus this parabola, right? Similarly, 0 to 4, bounded by this what? 0 to 4, bounded by, I mean, if you write your 0 to 4, you are getting the whole portion. But you need only this blue colored portion. So that means if you take the whole portion 0 to 4, then you have to subtract the white portion. Okay, and also we know while taking the, I mean, integral, suppose you have a to c, yeah, a to b fx dx, that is equal to what? A to c fx dx plus c to b fx dx, right? So this property can be used here. So anyway, we are not going to that much of complications here. So what we can write, required area. Required area will be what? Integral of, it is from minus 2 to 4 y of line. Y of line means the function in terms of y equal to fx representing the line, minus, again it is minus 2 to 4 y of parabola. Okay, this is the thing. So y of line is what we have taken here. Y of line we have taken 3 by 2x. We have written already, we can get it from rough sketch also. Yes, y of line is what? See, your equation 2 represents y of line. Okay, and equation 1 represents y of parabola. Right? Y equal to 3 by 4 x square, that is y of parabola. Y equal to 3 by 2 x plus 6, that is y of line. Okay, so let's take that. Yeah. Now required area is, as your integration is very simple, minus 2 to 4 y of line. Y of line is, you can write here, 3x plus 12 divided by, yeah, divided by 2. So that means half of this. Okay, dx minus 2 to 4 y of parabola. What is the parabola here? Just have a look on the rough sketch. Just, it is your 3 by 4 x square, right? Y of parabola is 3 by 4 x square. Okay. Okay, so you can write here 3 by 4 x square dx. Okay, so integration is not difficult, as I have told you earlier also. So it is 3x square by 2 plus 12x. Okay, limit from minus 2 to 4, right? Minus 3 by, okay, so this is for half is for this thing. One bracket is enough. Yeah, it is 3 by 4. Now here x cube by 3, right? Limit from minus 2 to 4. Okay, I'm just writing here 1 by 2. Now you can say the first term is into 3 by 2. So take 3 by 2 out. Now x square at upper limit is 16 minus lower limit is square of minus 2, this. Okay, plus half of 12. Okay, x. You can calculate in your own way. 4 minus of minus 2. Okay, done. Now next, minus 3 by 4. This 3 will come out. 3 by 4. 1 by 3. X cube at 4 is 64. Okay, minus at 2 minus 8 means it will be plus 8. Okay, so that is the thing. So this is equal to 3 by 4 into 12 plus, here it is 6. 6 into 6, 36, minus, you have 1 by 4, 64 plus 8, 72. Okay, so you are having here, 9 plus 36 minus 24. Sorry, this is 18. Okay, 72 by 4. Okay, so you are getting what? 18 plus 9, 27 square units. Okay, is it clear? When you are given line and parabola, area of the region bounded by a line and parabola, that can be done in this way. Okay, so whether the parabola opens towards, right side of x-axis or left side of x-axis, or upward direction of x-axis or downward direction. Okay, anything is fine. So next one is very, very simple. This question I have taken from NCERT exemplar. Find area of the region bounded by the curves y square equal to 4x and x square equal to 4y. So this question again you see, these two curves, both the curves represent parabola. Okay, one is the parabola which opens to the right of, towards right of x-axis, that is your y square equal to 4x. This is y square equal to 4x, and this one is x square equal to 4y. Okay, drawing the rough sketch is done, and shading part you can see. In the shading part you can observe, so the area bounded by two curves. Yeah, so it is very, very clearly, evident from the rough sketch. Okay, this parabola, I have taken only one question because you people are very familiar with parabolas and you are fond of parabola also, right? So yes, so this is the curve we want. This is the region we want to find. Okay, now you see where is where do they intersect? They intersect here. Okay, so this is the vertical line you have to, because we need a boundary wall for getting limits of integration. Okay, so now you can clearly see, first to start with given curves. Given curves are y square equal to 4x, okay, and x square equal to 4y. So I have taken very, very easy parabola so that you can relate to the question. Okay, so y square this. Now you see, getting the rough sketch is done, and again the shading, the required region is also done. Third step is finding limits of integration. So to get limits of integration, we need point or points of intersection of two curves. So now let's solve it. Here you see, from, you can replace x or y. So I would prefer to replace y. Now from 2 y equal to x square by 4. Okay, substituting this, putting this in equation 1. So that is what, so you can write here y square means x to the power 4 by 16. Yes, x to the power 4, yes, x square by this equal to 4x. Okay, so it means x to the power 4 equal to 64x. So this implies x to the power 4 minus 64x equal to 0. This is very interesting. So x cube minus 64 equal to 0. So you are getting x equal to 0, x equal to 4. Okay, so that is also evident from the rough sketch we have drawn. Okay, so x equal to 0 and x equal to 4. Okay, now required area. Area of the required region is required area will be what? So if you observe this, you see, so if I take, yes, I may write here A, B, yeah, so this portion basically the portion bounded by the curve y square equal to 4x. Whenever you take this bounded by y square equal to 4x, you are getting the entire region. Let me write here O, A, okay. Now again here I can write somewhere because this is coming like this only. Yeah. Okay, I may write area 1 and 2. Okay, so we need area of 1. So 1 plus 2. Okay, region 1 plus 2 means it is basically the whole area OAB. That is bounded by y square equal to 4x. But we do not need this white portion. I mean region half by 2. Okay, so it means this white portion, I mean this region 2 is bounded by x square equal to 4y. Right? So it means you take the whole area, region bounded by y square equal to 4x and subtract the region bounded by x square equal to 4y. Okay. Now this area of the region bounded by y square equal to 4x, this is what? This area is basically, yeah, you can take it from here, y equal to 2 root x. This one is your y equal to x square by 4 because we need y equal to fx format. So required area is what? It is from 0 to 4. Okay, bounded by what? I mean this portion we are taking this, I mean bounded by y square equal to 4x. It means 1 plus 2. We are taking entire OAB which is bounded by what? I mean y square equal to 4x. Means y of this, so 2 root x dx. But at the same time, while taking this OAB, we are covering 1 plus 2. But we do not need second region. So for that, what we have to do? We have to subtract. It is also 0 to 4 bounded by what? Bounded by the second parabola, that is y equal to x square by 4. Okay, 1 by 4 x square. So integration is very simple here. Twice of x to the power 3 by 2 by 3 by 2, 0 to 4 minus 1 by 4 of x cube by 3, 0, 0 to 4, right? So you are getting here 4 by 3. Now here 4 to the power 3 by 2, 4 to the power 3 by 2, you can directly write 8 here, minus 0, minus 1 by 12. Okay, 4 cube is 64, minus 0. Okay, the last step of this is, yes, we are getting here 4 by 3 into 8 minus 64 by 12. Okay, just let me write like this. 64 by 12, 4, 16, 4, 3. So you are getting 32 by 3 minus 16 by 3. That is equal to 16 by 3 square units. Okay, so once more you can check it. Twice of x root x, that is x to the power 3 by 2 by 3 by 2. So it is 2 by 3, 2 into 2 by 3, 4 by 3, x to the power 3 by 2 means 4 to the power 3 by 2 minus 0. Minus, here it is 1 by 12, x cube, limit from 0 to 4, that is 64 minus 0. Okay, so you are getting here 32 by 3 minus 16 by 3, right? So you are getting here 16 by 3 square units. So it means whenever you find area of the region bounded by two parabolas, so you can do like this. So step 1, drawing the rough sketch. Step 2 is shading the region whose area to be calculated. Step 3 is finding limits of integration. So finding limits of integration means you have to solve the equations of the given curves. Okay, and from the common points only we can see where the curves the curves are intersecting. The point of intersection basically we need to see, and from there we can visualize. So what should be the limit from which value of x to which value of x? Yeah, the interval you can say in mathematics language, in which interval we are calculating the area. Okay, and taking that interval as lower limit and upper limit respectively, we can integrate. Yeah, we can evaluate the definite integral and get the area. Okay, now our last question is, last question is find area of the, this is our question number 4, right? Find area of the region enclosed within the circle x square plus y square equal to 16 and the parabola y square equal to 6x. Also find area of the circle which is exterior to the parabola. Okay, so let's find the interior region first. Okay, x square plus y square equal to 16. This is the circle, center at 0, 0, radius equal to 4 units, and this is a parabola which is like this, opening towards right of x-axis, positive direction of x-axis. Okay, y square equal to 6x. So this is the rough sketch. Now drawing the rough sketch is over. So next we have to see, what is the, let me take this color. Okay, so here you have to see shading portion, the area. So as I said, first we are taking the interior portion. Okay, area enclosed between the curve and area enclosed between these two. Okay, once we get interior portion, the exterior portion can be obtained by taking what? Area of the circle, which can be taken as pi r square. Okay, so area of the circle minus the interior portion. That will give us area of the portion, the circle exterior to the parabola. Okay, so let's first focus on this interior part. So this is the area we want to find. Okay, now step 1, step 2 done. So now our focus is interior portion. Now you see, since there are two curves, then whose integration to be taken? Just to avoid that, we really have to be very, very specific. We have to see, okay, where are they intersecting? Okay, circle and parabola both are symmetric curves. Circle is symmetric about its diameter, parabola is symmetric about its axis, right? So it means area of the lower portion, area of this portion, the portion, the region below x-axis equal to area of the region above x-axis. So what I am going to do here, I will find area of the region above x-axis and double it, multiply by 2, so that I can get area of the whole portion, right? So first of all, we have to write the proper format. Given curves, given curves are first we are writing circle. Otherwise, you can write parabola also. X square plus y square equal to 16. So here y of circle will get later on. Parabola is y square equal to 6x. Okay. So we are writing given curves. Now the rough sketch part is done because we identified this is circle with center at 0, 0, radius 4 units. So this point is specifically it will be 4, 0. Okay. Now y square equal to 4x, parabola which is opening in the positive direction of x-axis and also vertex at 0, 0. Okay, done. Now second step is also done because after drawing the rough sketch we could identify which area we have to find out, right? So accordingly we have shaded it. Third step is finding limits. So in finding limits we have to solve the equations. Now y square equal to 6x, here y square can be replaced. Now substituting y square equal to 6x in equation 1. So x square plus 6x minus 16 equal to 0. So you can get x square. So here, yes, you can write here plus 8x minus 2x minus 16 equal to 0. Or you can write x plus 8 into x minus 2, that is 0, which gives us x equal to minus 8, x equal to 2. Okay, but looking at the rough sketch, what you can see, x equal to minus 8 is not coming because when the parabola is opening towards positive direction of x-axis, so x cannot be negative. So this value is rejected. Okay, we are rejecting this value. Okay, you know the reason I told you. So why are we rejecting it? Because we do not have any portion of parabola which is in the negative direction of x-axis, right? So our accepted value is x equal to 2. Okay, so as I have also discussed with you earlier, so getting y, I mean getting the point of intersection, x and y coordinates both are fine. But here we are not interested in y because we are going to find area and we are moving along x-axis. So we want x equal to a to x equal to b. Okay, so we are not interested in y and we don't want to waste time in fact. So we want to save time. Okay, so x equal to 2. Okay, so now if you can just observe, so here you see, if I take, I'm just marking 1 and 2. Okay, now the area above x-axis can be taken as area of the region 1 plus area of the region 2. So area of the region 1, you see, it is from x equal to 0 to x equal to 2. Okay, here x equal to 2. So x equal to 0 to 2 bounded by what? Which curve is associated with this portion? That is your parabola, right? The parabola, it means your y square equal to 6x, or you can say y equal to root 6 root x. Okay, now coming to region 2. Region 2 is from 2 to 4, x equal to 2 to x equal to 4. And the curve attached to this is circle. Okay, x square plus y square equal to 16. Or you can say y equal to under root 16 minus x square. Okay, so let's find the area then. So now required area is what? So you can write, yeah. So I'm talking about what? Area of the region above x-axis. So it will be what? Okay, so now 0 to 2, right? Bounded by y of parabola. Okay, plus it is 2 to 4 y of circle. Okay, so we are getting here area of the region bounded by the curve and bounded by two curves above x-axis. So multiply by 2 so that we can get the whole area. So here we are doing the first part of the question. Okay, interior region. Now y of parabola. So this is equal to twice of, so it is 0 to 2. So y of parabola is what? Your parabola is y square equal to 6x. So it is root 6 root x dx. Okay, plus 2 to 4. Y of circle is what? Under root 16 minus x square dx. Okay, only calculation part is left. So we, yeah, the twice of root 6. So this is x to the power 3 by 2 by 3 by 2. So I am writing here 2 by 3. Now here x to the power 3 by 2, limit from 0 to 2, right? Plus here it is, you can write, yeah, x by 2 under root 16 minus x square plus a square by 2, 16 by 2, that is 8, sine inverse x by a, that is x by 4. Okay, this is from 2 to 4. Okay, so this is equal to twice of, so here you are having 2 root 6 by 3. Okay, be very careful here. 2 to the power 3 by 2 minus 0. Okay, plus here upper limit minus lower limit. At upper limit 4 by 2, 16 minus 16, 0. Minus lower limit will be 2 by 2, 1. 16 minus 4, 12. Square root of 12 is 2 root 3. Okay, 2 root 3. Done. Okay, upper limit minus lower limit. Plus 8 into sine inverse 4 by 4 is 1 minus sine inverse 2 by 4 is half. Okay, so just let me, yes. Okay, so now we are towards the end of our calculation part. So here you have 2 to the power 3 by 2. So here you see, while calculating this, you are writing 2 to the power half this. So it means root 2, root 2, root 2, 2 root 2. Okay, so 2 root 6 by 3 into 2 root 2. Okay, then minus 2 root 3. Okay, yes, done. Yes, plus 8. This is your 5 by 2 minus 5 by 6. Okay, sine inverse 1 by 2. Sine 30 degrees 1 by 2, right? So 5 by 6. Okay. So let's calculate it very, yeah. So we are getting what? Twice of 2 into 2. 4 by 3. Let me write it. Now here root 6 root 2 root 12. Root 12 is 2 root 3. Okay. Right. Minus 2 root 3. Done. Okay. Plus 8 into 5 by 2 minus 5 by 6. 90 minus 30, 60. So it is 5 by 3. Right. Okay. So here you have 4 by 3, 2 root 3 minus 1 into 2 root 3. So twice of, it is 2 root 3. Here 4 by 3 minus 1, right? Plus 8 pi by 3. That is equal to what? Twice of, yeah, twice of, this is your 1 by 3, right? 4 by 3 minus 1, 1 by 3. So it means 2 root 3 divided by 3, right? Plus 8 pi by 3. So what can be taken common? You can get 2 by 3 can be taken common. So it means 4 by 3. Yeah, so yes, 4 by 3. Then you are having here 4 by 3 plus here root 3 root 3 minus 2 pi. Okay, square units. So this is area of the region bounded by circle and parabola, basically interior region. Now second part of the question is area of the region, exterior to the area of the region exterior to the parabola. Okay, area of the region means basically circle. Okay, exterior to parabola. So that can be taken as area of the circle minus area of what? Area of interior region. Okay, so I hope you are clear about this. So area of the circle will be what? So radius is 4. So pi r square means you can write here 16 pi minus interior portion is, you can have here, yes, 4 by, you can say, yeah, root 3, 4, let me write it completely, 4 root 3 divided by 3 minus 8 pi by, why it is minus, it should be plus, no? Yes. Okay, the plus 8 pi by 3, right? Yes. Okay, I've taken 2 common here. Okay, 4 by 3, this should be 4 pi. Okay, let's make the correction. Okay, so we have taken 2 by 3 out. So here 2 by 3, you are getting root 3, 2 by 3, you are getting 4 pi. Okay, so yeah, 16 pi minus, this is 4 root 3 by 3. Now here it is 16 pi by 3. Okay. Okay, so you are getting 16 pi by 3. Yes, 16 pi by 3. Okay. This is. So now next you can have 16 pi minus 16 pi by 3. Okay. Minus 4 root 3 by 3, or you can write 4 by root 3, that is up to you. So here we are getting 48 minus 16, that is 32. 32 pi by 3 minus 4 root 3 by 3. What can be taken common? We can write here 4 by 3 can be taken common. So you can get 8 pi, right? Yes, minus root 3. Okay, square units. Okay, so let me check it again. So 4 by 3, you can take 4 by 3, so 8 pi, yes, minus root 3 square units. So is it clear? So because in last question we have actually covered 2 questions. One is area of the region bounded by circle and parabola. We have considered interior region as well as exterior region. Okay, so these are some of the questions in store for today's class, and the next we will be coming with some other course, right? So thank you so much, and in case you want to share the video with your friends, so please do that, and in case you have not subscribed the channel, please do subscribe. That will really be a motivation for me. Okay, so thank you so much. Thank you once again.